So, you like birds? Well, here's where the bird story starts. Dirt. Soil, if you want to get fancy. But to get here, we have to tell a short story of a few billion years. Glaciers, rivers, wind, and lichens carve up rock. Millions of plants and animals die over centuries and millennia, contributing their organic chemicals to the mix. And the great cleanup crew mixes it all in the ground, making a perfect place for plants to grow. So we end up with a green planet, using carbon dioxide, water, and sunshine, photosynthesizing all of this into sugars and starches. Now keep this in mind, except for faster seed dispersal, plants don't necessarily need us, or any animals for that matter. They make their own food. We animals, being resourceful, take advantage of that. Fruits, vegetables, berries, green leafy stuff. We spend a lot of time at the salad bar, if we are herbivores, which are plant eaters, or omnivores, plant and animal eaters. But from way back in time, maybe 480 million years ago, according to biologists and archaeologists, first in line to eat the plants were the insects. Insects, especially in their caterpillar stages, ate plants and multiplied like, well, insects. Along came a spider and sat down beside her and ate insects. Some insects decided to be predatory and began to eat each other. Amphibians, then reptiles, began to eat insects and spiders and, yep, plants. Eventually, over millions of years, nature smiled on some reptiles who began to walk on two legs, and then grow their arms and fingers, and then jump farther by growing feathers for gliding. And finally, after 330 million years of nothing but plants and bugs and amphibians and reptiles, we got our first birds. An asteroid paid a visit and wiped out the giant reptiles, the dinosaurs. And the birds flew to where it was safer, and the first mammals somehow managed to escape the fate of the dinosaurs. And then another 65 million years goes by, and here we are, today, at the apex of animal development. Maybe another step up. Nope, not yet. Okay, a little better. If we were to pack geologic time into 24 hours, the first 23 hours, 59 minutes, and 59 seconds would go by before humans and civilization even showed up. This story took a few minutes to summarize, but it took a ridiculous amount of time to actually happen. And in that ridiculous amount of time, here are the results. We now have 450,000 known species of plants in the world. We can't begin to estimate the number of individual plants in the world, but satellite estimates of just the number of trees is 3 trillion. Before humans clearing land, it was twice that many. We have removed half of them. We probably have 6 million species of insects. We have 10 quintillion, that's 19 zeros, individual insects. Now those are not understandable numbers for the human brain. They are uncountable living things that took uncountable years of the E word to get as diverse as they are now. So let's toss in at least 160,000 species of spiders, most of whom eat insects. And then probably 400 billion birds of perhaps 8 18,000 species eating plants and insects and spiders. That's the big picture. The big picture. 8.7 million species of plants and animals humming along for millions of years, eventually getting to a somewhat fluctuating state of equilibrium, a balance. Birds, spiders, bats, and other insect predators eat untold numbers of insects, controlling their ridiculous reproductive capacity, but not too many of them. Insects nibble on trillions of plants, but not too many of them. It's about balance. The balances in nature are not steady state, but on a constantly changing roller coaster of predator-prey populations that grow and shrink together in a dynamic balance. Nature can be messy and beautifully balanced at the same time. Now, occasionally that balance gets ambushed by the unexpected. An asteroid might crash into Mexico and wipe out giants called dinosaurs. Geologists say that was only the latest one. Our sun might decide to take a cat nap for 1,000,000 years now and then, and we get an ice age. Luckily, it usually takes a few thousand years for it to fall asleep, and another few thousand years to wake back up. And animals move and plants can usually adapt without getting very unbalanced. Sometimes the sun has too much coffee when it wakes up, and it makes things hotter than usual. It was that way 5,000 years ago from today, but again, it was a slow warming and a later slow cooling. Another kind of unexpected ambush, for example, would be when a species of animal gets so smart they learn to use most of the things on the planet just for themselves. That could really throw things out of whack in a big hurry. An animal like that could burn so many things they could maybe change the whole climate. But it's hard to believe that an animal like that wouldn't also be smart enough to modify their own behavior and follow the rules of balance that nature has perfected over those millions of years. Well, some would. All that is the big planetary picture about big planetary balance. But there's something else you might want to know, because you don't just live on a planet. You live in a place on that planet, and that place has its own animals, its own plants that live in their own balance. Continents are different from each other with different climates and topography and ocean currents, and they each have their own plants and animals and their own balance. And on each of those continents, there are places where the weather is different, or they are divided by a mountain range or a desert. And on that mountain range, the weather is different at different elevations, so the plants and animals are different as well. Or the weather might be influenced by being close to oceans, or far away, or by being closer to the equator, or to the North and South poles. In each of those hundreds of different places on the planet, the plants, and therefore the animals, are in their own balance, shaped by millions of years of adjustments, most of which are still going on. If they have been in that place for a very long time, living in balance with the other unique and old beings there, they get a special title. They get to call themselves a native. The natives are all different from each other, but over time, they have learned to fit in. They may have complicated relationships with hundreds of other natives, but they fit in. They don't change the balance. Every plant on planet Earth is a native to a certain place. The plant and the place need to live together because they have for at least thousands of years, if not millions. So all of the other living things that are native to a place have intricate relationships with the native plants. And the pathways are likely through the native insects or herbivores that eat native plants, often only native plants, and sometimes only one native plant. Here's a local Flathead Audubon specific example. Owen Sour Wine area, which Audubon manages, is a beautiful and rare, in Montana at least, river bottom conjunction of two rivers. Huge and old black cottonwoods tower over a subcanopy of huge and old chokecherry trees in the 8 feet higher upland of the old floodplain. The rivers have downcut and left the area higher and drier. In the seasonally wet abandoned river channels, cottonwood seedlings and saplings still grow. All of us bird nerds who frequent the area know that red-eyed vireos are very common there. In May and early June, the males are singing, "How are you? I am fine," songs up to 40,000 times per day. Then it gets quieter as the pairs are busy feeding perhaps 6 mouths instead of 2. The hatching of the chicks, at least in Owen Sour Wine, correlates exactly with the hatch of cottonwood beetle larvae, increasing the high-protein food supply multifold. So this is one linear relationship of black cottonwoods to cottonwood beetles to red-eyed vireo chick survival, and it's one among millions whereby native plants feed native insects who feed native birds. Nowhere is there a non-native species that fits into most of these relationships. Not only do non-natives take up valuable space, but they often have negative relationship with natives. Our Owen Sour Wine area Hall of Shame example is common buckthorn, originally introduced as a decorative, which leaves out earlier, drops leaves later, grows faster, chemically inhibits other native plants from growing nearby, toxifies the soil to all amphibians, and has berries which are cathartic, read diarrhea, to birds and can sicken them. It also supports no native insects. When you head for the nursery to buy decorative plants this spring, the first question to ask, is it native to here? If not, you might want to treat it like the bomb squad would.
When you purchase a non-native plant, you run the risk of buying something that may become the next noxious weed. And it doesn't have any ecosystem services. It doesn't promote reproduction of insects. And that's the huge difference between native plants and introduced species.
So here are some examples of how important native plants are to native insects. I think most people know that monarch butterflies eat only milkweed leaves. Gillette checker spot butterfly eats only twinberry honeysuckle, found mostly in avalanche shoots. It gets pretty specific out there. Add in birds, bay-breasted warblers eat almost exclusively spruce budworms, which only feed on native spruces and firs. People often talk about birds favoring certain types of habitats, but they skip a step. Yellow warblers like to live in willows next to the water, not because they like the willows, but because they like to eat the insects that eat the willows. American redstarts live in alders because they like the bugs that eat alders. Tennessee warblers hang around bogs and wet fens because they eat the insects that live there. There are thousands of examples like this. Ruffed grouse eat seeds and in winter eat almost exclusively male, not female, aspen buds in the tops of trees. But in summer, mom grouse keeps chicks moving on the ground so they can eat insects and grow quickly. Even when it seems like a sapsucker sucks sap from the machine gun holes they make in birch trees, they are mostly there for the insects that eat the sweet sap. 96% of bird species raise their young on insects, even if the adults eat only seeds. Goldfinches like thistle seeds to eat, but they feed their young on insects that like thistle. Chickadees need about 6,000 insects, mostly caterpillars, to raise one clutch of chicks. These are native insects who eat native plants. In total, birds worldwide eat 400 million tons of insects each year. That's the equivalent weight of 66 great Egyptian pyramids in Giza. Yeah, mind-boggling. We humans think we have our own human communities of teachers and mechanics and bankers and carpenters and car salespeople, but we make three big mistakes. We think our community is separate from the big community of plants and animals. It's not. And we think we get to play by our own rules. We don't. We also consider ourselves native if we're born in a place. We're not. In North America, even Native Americans were really just starting to become native to this continent, starting to really fit in and live by native rules, native biological rules, after probably 20,000 years. And then we mowed down native plants and covered half of this continent with non-native crops and concrete and subdivisions, fostered the animals we considered good for us, and killed the bad for us. And we brought with us other definitely not native species. Despite thinking we were the smartest beings around, we didn't know. Millions of years of fine-tuning the balance in half of those native places down the drain. But here's the pretty good, could have done worse news in official Montana speak. We still have half of our mostly native habitats left. We can protect them, and we can restore at least some of what we messed up.
If we're going to have birds, we've got to think about it. We have to really push habitat in order to keep our birds.
So I found out about the rain garden program through the Flathead Conservation District, and I had this plot of grass in the back that wasn't very useful for anything, and it wasn't growing grass very well, and decided this would be a really cool project to include in my backyard. How a rain garden works is it will take the watershed off of the roof to be filtered through our natural systems and then into our groundwater. So rather than rolling directly onto asphalt or onto concrete and collecting pollutants, which then goes into our groundwater system, once I had all of the sod out of the yard, then I amended the soil and brought in some compost and some other elements to help add a little more nutrition to my soil substrate so that things would want to grow there. I had a small grant also through the Rain Garden initiative that allowed me to go shopping at the Center for Native Plants and Whitefish, which is super fun. I sort of geek out on the plant. So every spring it's something I get to look forward to, and everything blooms at a different time. They have different colors, they bring different critters. It's really nice to see some of the stuff that we see in the woods naturally in town. rather than bringing in invasive species that can blow from yard to yard and really sort of take over and squeeze out our natural flora and fauna. I really liked this element. And the other bonus points for having native plants is you really don't have to do anything with them. They already know how to grow here. You don't have to cultivate, you don't have to help them along, you can just kind of enjoy them. So again, less mowing, less work, more flowers and more pretty things. That was a win-win for me all around. This is a small way I can give back by helping produce better quality water that goes back into our system.
So, you want to help? Here you go. And watch the birds that eat the bugs that munch on your perfect restored habitat. Can you imagine how much we could fix if we can talk all of our 360 million neighbors into doing the same? We would be giving ourselves half a chance to hang around for another few thousand years.